Here we are in section 2.5 with the solutions numbers 30 through 33, and this is working together. These are work rate problems. Now again, if you have the times of two people being able to do a job, say A and B, and you want to find out their total times, these don't add or subtract or multiply or divide to T. You've got to change it from times into rates. And that's what happens. It's the reciprocal of this. If he can do it in a certain number of hours, then he can do 1/8 of that every hour. And these do add to give us that one. So this is the formula that we're going to use. So Molly can mow a lawn in 3 hours, and her little brother can do it in 6 hours. How long will it take working together? So we're trying to find T. So 1/3 of the job plus 1/6 of the job being done every hour is how fast they are working together. And then reciprocal it back, and that will find their time. So 2/6 plus 1/6 is 3/6 equals 1 over T. 1/2 equals 1 over T. So flip them over and you get T equals 2 hours. Excellent. Number 31. So a large pipe and a small pipe are both being used to fill a swimming pool. A large one can do it in 6 hours. So that means that the rate for this one is 1/6. It will fill 1/6 of the pool every hour. The other guy can do it in 10 hours. That means it's 1/10 of the pool every hour. So 1/6 plus 1/10, that's how fast they can both do it together, which is the reciprocal of how much time it will take for them both to do it together. So let me see. Common denominator of 30. So we're going to times by 5. Times by 5, you get 5/30ths. Plus times by 3. Times by 3. 3/30ths. That gives us 8/30ths. 1 over T. Flip it over and we get the total amount of time is 30/38ths of an hour, which reduces down to 15/4ths, which is 3 3/4 of an hour, 3.75 hours, or 3 hours 45 minutes. Cool. Number 32. Ben can clean the whole house in 4 hours. So that means he can do 1/4 of the house every hour. That's his rate. But it only takes 3 hours if his son is helping him. So the total time, the total rate is 1/3. This is the total thing right here. The son. So how long can it do it by himself? So we have 1 over Ben plus 1 over his son. We don't know what that is. Let's call it B. It has to equal the rate of the total time together if it takes 1/3. There we go. So we get 1 over B is going to be 1/3 minus 1/4. Common denominator, we get 1 over B equals times by 4 times by 4, 4/12ths minus 1/12. Nope, 3/12ths equals 1/12. So flip it over. The boy can do it in 12 hours by himself. And you can test that and double check. 1/4 Ben's rate and 1/12 of the job will equal up to 1/3 of the job every hour. All right, number 33. Marie has been hired by a mailing company to stuff envelopes. She can do her day's work in 6 hours. So hers is 1/6 hour, 1/6 of the job every hour. If she has an assistant, she can do it. They both can do it in 4 hours. So this is that total time, which is smaller than that. So the total rate is 1/4. So it's 1/6 plus her assistant doing it alone. We'll call that B. And that equals 1/4. So again, this is the capital T here, and this is the A right here. So 1 over A, that's the rate that Maria can do it all by herself. The rate with her assistant and her working together. And so we get 1 over B equals 1/4 minus 1/6. How much is that? Common denominator 12 times by 3 times by 2 times by 2. So we get 3/12ths minus 2/12ths. Hey, that's cheating. Look at what that came out to be. That is 1/12. So reciprocal, reciprocal. The assistant doing it by herself can take 12 hours. Did not see that coming. Alrighty, good deal.